Channel. I am Anshul. So today we are going to discuss about the stack data structure. So before going forward on stack, we must need to understand what is data structure. So in computer science, data structure is a way to organize, manage, store data so that it can be used efficiently. So when we are storing data and when we are retrieving data, that should be in an efficient manner. So in terms of data structure allow user to access, store and data very efficiently. So data structure define relationship between data and operation perform on data like read, create, update, delete. These are the actions which we need to perform in the data on data using data structure methodologies. So we have different data structure which could be used for different situation or solving problem. Like if you have any problem in which you have to pull the data which is in from LIFO method, like last in first out, whatever goes last that has to be pulled out first, then we have to use stack. If we have any problem where we have to implement the first in first out, like the whatever goes first then that has to be pulled out first, then we have to use queue. So today we will discuss about the stack only. So what is a stack? So many of you have seen, means everybody has seen that pile of plates in our home or in our parties. We see pile of plates. So plates, you can think of a stack as a pile of plates where you put plates on top of another. So we have multiple plates. If you wanted to pull any plate, how you will pull? How you will pull? You will pull from the top of it. So whichever is at the top, you need to pull that plate first. And let's suppose if you wanted to pull the third plate, then how you will pull that? You need to remove first two plates from the stack, then you can pull the third plate, right? So this is called stack. So what could be the operation on a stack? In programming term, we have mainly two terms to be used for a stack. One is push, one is pop. So as you can see here in the example, we have empty stack. You can think of it as an empty array. So once we are pushing in any value into it, then this is called as push. So we are pushing one element, like here you can see we have one empty stack, and here now we are going to push one element or inserting one element into this array. So this is called as push operation. So another one, here you can see we have pushed one another element. Here we are pushing one another element. Now if you wanted to pull out the element from the stack, then that is called as pop operation. So once you wanted to pull some element from that array, then that is called as pop operation. If you wanted to pull a plate from the, let's suppose if I take example of the pile of plates, if you wanted to pull a plate from the pile of plates, the very first plate which you have pushed at the very last time, so that is called as pop. And if you are putting a new plate on that pile of plate, that is called as push. So here we are just viewing the example in terms of programming. So we have empty stack, empty array, and here we are pushing one element one by one. And if we wanted to pull the element from the stack, then that is called as pop operation. But you could see here there we have multiple operations which going to be performed on stack. So first one is push, we have already discussed. Next is pop, we have already discussed. What is empty? So if you wanted to pull any element, then we have to check the stack must have some elements in it, right? So we have to check that is the stack empty. If its stack is empty, then we cannot pull any element from it. So similarly, is full, which will check that stack is full. Let's suppose we have stack limit is 3. If we wanted to push one more element into this stack, then it is not possible. So first we will check that stack is full or not. If stack is full, then we will tell user that stack is full, you cannot insert more element into it. And similarly we can say to user that stack is empty, you cannot pop any element from this stack. Next is peak. So what is peak? Here peak means you wanted to get values without removing it from stack. Let's suppose here what we are doing, we are pulling out this value, and I just wanted to print this value, not gonna pull this values, and then that is called as peak. We will see later in the example. So what is the working of stack? So stack could be implemented using two methodologies. First is array, next is linked list. So here we will be using array, which is linear data type. So how stack we are going to implement the stack here? In the very first step, we need to initialize the array to store the stack element, which is a very basic step, and we would need one top variable, which could be initialized with -1. We will see how -1, why we are initializing it with -1. So as you can see here, I have already given an example. If top is minus is equals to -1, then stack is empty. So in order to check the stack is empty or not, then we need to initialize it with -1. Why we have initialized it with only -1, that we will see in the next slide. So now if we want to push element into the stack, then we will increase the value of top. Let's suppose if we have very first element to be inserted in the our stack, then we will increase top value from -1 to +1. Means if we will increase 1 from minus, if we will add +1 to -1, that would be 0. And similarly we will increase the value whenever we are pushing element into it. And when we want to pop the value, then we have to decrease the top value by 1. Let's suppose we have inserted 3 values into a stack. Now I wanted to pop out one value. So we have to decrease the top by -1. This top is a variable basically. So after this, when we have discussed the pushing of element, pulling of element. Now when we will pushing value into a stack, we will check is stack is full or whether it is empty. So if a stack is full, we cannot insert any element or we cannot push any element into the stack. And if stack is empty, then we cannot pop out any element from the stack. So those two conditions we would be checking. So how, so as I told you, like I will tell you that why we have taken top value -1. So as you can see here, we have empty stack and our top value is -1. So whenever I'm going to push value into stack, I'm gonna take it as top equals 0, means we have increased value of top from -1 so that I can store into the stack position 0. So here you can see that top value is 0 and we have pushed element on the stack index 0. Similarly, we have increased the index of top and we are just pushing value on stack position index of position 1, which is value is 2. Similarly, we have pushed item 3 value 3 on top of stack index 2. So let's suppose if I wanted to pull the value or pop the value from a stack, then what I need to do? I need to return stack whatever the last element was there, the stack element index was 2. So I have to return stack 2 and then I will decrease the value of top. As you can see here, I have decreased. First I have pulled the element or popped the element, then I have decreased the value of top. Pop pop the element, then I have decreased the value of top element. So let's do some practical hands-on. So here I'm gonna try this with C language. So here we have our main method and we need to define some methods over here. Let's define those methods. How those methods will work, we will see. So here we have to define few methods. First, we will define our methods in C language. So oops, stack empty. So in order to check the stack is empty or not, we need to define this method. Next we will define integer is stack full. If our stack is full, then this will return 1, otherwise it will return 0. That means the stack is full, and if a stack is not full, then it will return 0. So in these functions we will basically define our conditions. Next is void push item. So item would be of type integer. Void pop means we will pop element using this function. Next we will use void peak. That's all. We have defined our functions. Now we will implement these functions. Integer is stack empty. So in this function we will check if our stack is empty. So I already told you that we are going to check that stack is empty or not. We will check the top value, right? So we need to define some variables here. First we will define our maximum limit. What is the maximum limit of our array? So let's suppose I have taken it as a 10. So what would be the array size? I'll be giving it as 10. I'll define it array in the next line or two. Next I will define top, variable top as -1. Next stack, and what would be the size? As I told you, the size would be the maximum of stack would be 10. Size would be 10. So is stack empty? In order to check this, we will check that what is our top's value of top. So here what I'm doing is I'm checking that top is equals to -1, then please return true. That means return 1. 1 we are just interpreting as a true, else return 0 means stack is not empty. Let me put some comments over here. Stack empty. Next is stack full. So we will define here the method is stack full. In this method we will define is our stack full or not. So here also we will check the conditions. Top equal max -1. So what is the max value? So our index is for array we are going to start index from 0. So 0 to 9. So we need to check here max -9. So 0 to 9 position we will check. If top is equals -1, then that means if our stack is equals minus max -1, that means 9. So we reach the limit. So we can return 1. Is stack is full? Yeah, it's full. Else what we will return? We will return 0. Means our stack is not yet to have some elements. Next is stack full? Now we will define our method push int push, and we will get value from user or from our function. So integer item. So this is our push function. So how we will do this? In order to push something into the stack, first we need to check whether our stack is full or not. If stack is full, we cannot insert more elements into it. So first we need to check if is stack full. I'm just negating this. So stack is not full. If stack is not full, what we are going to do? We are going to add value into the stack. So on what place we are going to add value? So first what I need to do, top plus plus means now what is our top value? Top value is -1. Now if I plus it, then that means +1 means we are at 0 position. So top equal sorry, single equal basically. So stack top item, whatever item we are going to store on top of stack. So we have written our code here, and else let's suppose our stack is full. So here we are checking is the stack full? Negation means if a stack is not full. So because this function will return 1, so that means true, and we are negating this means false. So else printf stack is full. That's it. Next we will pop our element. So in order to pop our elements, we need to check whether our stack has some values in it or not. So for that we have already defined one method is stack empty. Is stack empty? If stack is not empty, then what we are going to do? We are going to pop the element. So how we will pop the element? So stack top, I'm gonna print this directly. So element here percentage d, because we are going to print integer value, percentage d. Next, and I'm gonna put minus minus here, so this will decrease the value of top. So we can do this like this as well. If it is, it might be confusing for new users. So I have what I did, I have just popped the element, then I have decreased the value of top, so that our pointer will be on the next top. Means if you are on the top, like we have inserted three elements, so what would be our top? Three. So once we are just popping our element, then it has to be 2. Else printf stack is empty. That's all. So this is the code for pop. Next is a peek. It's an additional function basically. So void peek, we are going to implement this function. In this function we are going to just print. We are not going to increase or decrease the value of top, so that because we are not returning anything. Peek value percentage d, and here stack top. So what is the difference between this and this function, pop and peek? So if you can see here, we have just decreased the value of top, but in here we have not decreased any value for top. So now let's call these functions one by one so that we can check our results. Push 11, push 12, push 13. So I have pushed three elements. I have called same function thrice. Now I will pop out the values. Pop, pop. Now we will check and try run our program. It's working or not. Oops. Okay, so from push we need to return something. So here we have provided as void, and here we are providing as integer. Now I have changed it, and I'm gonna print this variable as well. Printf push element what we have pushed. Okay, just bear with me. So now here we are not going to return anything, so we are going to use it as void. What's our definition? Void for push, pop, and peek. Yeah, I think this should be working now. Okay, so here we have not added comma. Now we have added comma. So you cannot see the results properly, so I'm just adding /n at the end of this so that you can see it clearly. So here you can see, guys, we have pushed 11, 12 and 13. we have pushed 11, 12, 13, and how it is popping out. So when we have popped our element, this function will got called. Like if you can see here, we have checked is stack empty. No man, its stack is not empty. So this will pop element stack top. What is the top value? Means top value is 3. How the top value gets 3? Let's run through this program. First we have pushed 11. So what function will get called? Push. If stack is full, no, stack is empty. So top value will be 1. Sorry, 0. From -1 to 0. So here it was -1. Now stack value is, top value is 0. And what is the item we are going to store? So item is 11. So 11 is getting stored in it. Now we have printed out our pushed element. Here you can see this. Next time we are pushing 12. So let's see. Next item is 12. Stack is full. No, top value would be 1, because last time it was 0. Now it will get increased by 1. So we have stored on the very first position of the, sorry, next position of the stack, and here we are just printing this out. Next we will be pushing the 13. Same way, the top value will be 2, and we are just storing on top of 1. After 1 we are storing it, and now pushing element, we are just printing this, pushed element 13. Next, what is our function? Pop. So we are popping out element. So here if you can see, stack is empty. No man, our stack is not empty, because in stack empty we are checking that top is equals max -1. Max is 10, -1 means 9. Top value is 3. Sorry, 2, not 3. It is 3. 0, 1 and 2. So pop element stack top means pop element stack top. Top means what is the top value? It is 2. So it is just popping out the value. Then we have decreased it. Now again we have called the pop. We have called the pop, then the value getting decreased and printing the value. Now value is 1. Now again we have popped, and we are going to decrease the value of top. So value is 0 now. Now if I pop it again, what would happen? So last value was 0. So next time it will come here, it will check is the stack empty. How it is checking? Top value is -1. Sorry, we are not checking the right function. So top value is -1, equals -1. Yeah. So this will not pop the element. This will come here. Is the stack empty? No. Yes, stack is empty, because here we have negated this. So stack is empty. Now this will print stack is empty. So likewise, if you see the result, stack is empty. That's all friends. That's all for today. I hope you will like this video. Just click the like button, and please subscribe my channel for more videos. Thank you.